Hello guys, today we're going to go over 6.5, the properties of logs. We're going to go over examples 1, 2, and 3. Now, this is a subject that requires a lot of practice, not that difficult once you get it down, but it does require thinking, especially when we're expanding or condensing logs, but you'll see that in a little bit. So these are the properties of logs, and even though it looks kind of confusing, it actually isn't. All they're telling you is that whenever you're multiplying a number times a log of the same base, you can break it up into log of m plus log of n, of course with the same base. So for example, if they tell you log 2 times 8, or 16, it's the exact same thing as log base 3 of 2 plus log base 3 of 8. So you're kind of like distributing the log and then adding. The same thing applies for division. Now if you think about it, when we multiply we add, and then the inverse. When we divide we subtract. So say they give me log base 5 of 6 over, and one thing, don't think that you'll be working these logs in your brain without the calculator. These are done mostly using the calculators, as you'll see, but there are some cases in which you can actually figure them out. But for the most part, calculator. Now in this case, log base 5 of 6 over 8, you can turn it into log base 5, the same base, of the numerator minus log of the same base denominator. That's simple. You break the division into a subtraction. The numerator goes in the front, the denominator goes in the back, and again, the bases never change in any of these operations. You're going to distribute the exact same log. The final one, the final property, is also quite simple. Let's say you have log base 3 of 8 to the 7th power. All that happens when you have a power up here is this number comes to the front. 7 times log base 3 of 8. Now, why am I saying that most of the time you're going to be using a calculator? There are some times that you can actually work these problems if you're smart. For example, let's say I have log base 16 of the number 2 plus log base 16 of 8. Most of the people will say calculator. I need a calculator for that particular problem. Who the heck knows what this is? Who the heck knows what this is? And then I have to add those two numbers that nobody knows what they are. Well, let's use these properties. You know, this is a bidirectional process. You can also condense them into products if they have the same base. They both have the same base. So I can put this addition together as a multiplication. So I can turn this into log base 16 of 2 times 8. And 2 times 8 is 16. So that turns into log base 16 of 16. What number do I raise 16 by in order to end up with a 16? You should all know the answer. The answer is 1. Now, if you do this in the calculator, you're also going to get a 1. You're going to get a crazy decimal here, a crazy decimal here. When you add them both, you're either going to end up with 1 or a number that is infinitely close to 1. It should be 1. Okay? So, just like you break them, you can also condense them. So now in more, understandable terms, when you go in this direction, that's called expanding a logarithm. I'm taking an expression that is kind of bunched up and expanding it. When you're asked to go in the other direction, you're condensing. I have an expression with multiple logs of the same base, and I'm just going to condense them to try to end up with just a single log of that particular base. But that's just going to go, that's going to happen a little bit later. Right now, let's go over example 1. I'm going to use these properties to solve all the problems that are giving me in example 1. Now in example 1, this is very important. they're giving you the values of certain logs. So right now, they're telling you the following. Right there in the instructions, log base 2 of 3 equals 1.585. And they're also telling you log base 2 of 7 is 2.807. Again, you don't have to remember these numbers. You don't have to know this. When you're working with these types of problems, they will give you the values of the logs you will be using. Otherwise, have a calculator at hand. Now, if we look at the first example, A is telling me log base 2 of 3 over 7. Again, when I look at my properties, this is the division or the quotient property. So what do I do here? I put the denominator in the front, log base 2 of 3 minus log base 2 of 7. And my denominator goes at the bottom. And just in case, that's a 7, not a 27. That's log base 2. And since they're giving me these values, I just plug those two values here. I know that log base 2 of 3 is 1.585, so I just substitute that value. And I know that this value is 2.807. Now what do? Either, you subtract using pen and paper or calculator. However, whatever restrictions they give you, you use. But it's just basic arithmetic. The answer to that division, again, given the values without using a calculator, is negative 1.222. Or without using a calculator to plug in the log, but you can do the subtraction. That's all you do. So again, what did I do here? I expanded using the properties of the logs, turn that expression down here, and then I substituted those values for the ones that are being used in the expression. Then basic arithmetic gives me the actual answer. That was example A. Now let's go over example B. Example B tells me log base 2 of 21. Pero profe, they're not giving me a 21. They're giving me 3 and 7. Oh my God, crisis. Don't freak out. Again, this is a little puzzly, but it's very simple. Most of you already know what you have to do. Is 21 not the product of 3 times 7? Is that not the same thing as 21? Yes. And when I have a multiplication of 3 times 7, do I not break it up and turn this into an addition? Yes. So all you have to do here is turn that into this addition, log base 2, 3 plus log base 2, 7. Substitute the values. And now instead of subtracting, I'm adding because it's multiplication. Basic arithmetic gives me an answer of 4.392. So again, even though they didn't give you a particular number you had here, they gave you a number that you could reach either multiplying or dividing those values. Okay? Again, these are the rules you're going to end up using. Again, let's try the following. They're telling me log base 2 of 49. Now this one's a little bit tricky, but this problem can be solved using these rules. Now first of all, is there any way I can multiply 3 and 7 to end up with 49? Well, there's one way. 49 is the exact same thing as 7 squared. Yes or no? Because 7 times 7 is 49. Now, there are two ways you can work this problem, and they are both correct. You can turn this into a multiplication. 7 times 7 times 7. And since this is a multiplication, you just add this number, log base 2, 7, plus log base 2, 7. And that's perfectly fine. But it's faster if you use the exponents and then multiplication. Again, 7 times 7 is the exact same thing as 7 squared. Since this is a power of a log, all I have to do is the 2 comes up in front. The 2 is now multiplying. And now I substitute my log base 27 for my value. Kind of like in school, my erasers here, yet I'm just erasing with my hand or my clothes. Guess it's difficult to break some habits. I'll try. So I substitute that value right there, and now you multiply by 2, and that's going to give you the answer, which is 5.614. Okay. And again, if you add this twice, 2.807 plus 2.807, you end up with this. But I believe that multiplying this number by 2 is way faster, and there's less chances of getting a mistake than adding it to itself. 7 plus 7 carry 1 plus 0. It's just multiply. It's a lot faster. But they are both correct. They are both correct. So that takes care of example 1, going over a brief review of these problems. And that's just how you'll get them in the test. Maybe a little bit more difficult, maybe a little bit easier. They're going to give you 2 or 3 values, and then you have to work with those values. Either you can use them straight up, like in the first example, or you might have to break a number into these factors, or you might have to square these numbers to end up with another number. But it's pretty much the exact same process. That takes care of example 1. Now we're going to go over examples 2 and 3, which is condensing and expanding. Again, it's going to start off pretty easy, but then it's going to complicate itself a little bit. So as you can see here, I begin by expanding, and they give me ln 5x to the 7th power over y. Okay, now the first thing you do, you never work with the exponents first. You try to break up. If it's a multiplication, you break it up first. If it's a division, you break it up first. And you'll see how it works. It's not that simple, because some students only work half of the problems. They don't continue working. I don't know why. So let's look at this example. Step 1, I have a division, and I have a natural log, base e. Just leave it as ln. So for step 1, I'm going to just turn it into a subtraction. That was pretty straightforward. I have my denominator here and my numerator here. I distributed my log, so that's good. I mean, that's about, 30% of the work. You can see here, I have a power, but I also have a multiplication, 5 times x. So again, you're going to leave the exponents for the end. I'm going to break this log, which is a multiplication, into an addition. ln 5 plus ln x to the 7th minus ln y. So basically, again, using the properties, I broke this product into an addition. Now all that's left is use the power rule. This exponent comes up here and is multiplying your ln x. And that's it for expanding that polynomial, that particular log. Sorry. Again, remember, expanding, you begin with a pretty bunched up single log, and then I break it down into multiple different logs. That's called expanding. Note that there is no parentheses here, so the power only applies to the x. Let me give you guys a different example that's not in the book, but let's see what would have happened if I had a parentheses here. If I had a parentheses here, I would have broken it up like this. So again, I break up my division as normal, but since there's a parentheses, I do the power first. This turns into this. And now, since this is a product, I can get rid of the parentheses. Since this is a product, I break it down into 2 equal logs, but that includes the 7 that's in front. So we're turned into 7 ln 5 plus 7 ln x minus ln y. So just make sure you're doing the proper processes depending on whether there are or are not parentheses. It's just practice. So that would be example 2, expansion. You will be doing that a lot for homework, you'll see. Now let's go over example 3, which are the only 3 examples we're going to be going over today. Example 3 is condensing. I begin with a very, very big log, and then I just try to fuse it all into one. So let's see. I'm given log 9 plus 3 log 2 minus log 3. Now, here we're going to work backwards. So we're going to try to turn everything into an exponent first, then put together my multiplications, and then form the division. So for example, remember, when they don't give you a log that's called a common log, which has a base 10. Never forget that. So they all have the same base. Perfect. So let's work with this 3 first. This 3 turns into a power. So I would end up with log 9 plus log 2 to the 3rd power minus log 3. Now, since we're trying to condense, it's like reverse. Well, it's kind of like, well, not simplifying. We're trying to just bunch it up as much as possible. So I'm going to turn this exponent and this base into a number. 2 to the 3rd power is 8. Great. Now, I'm going to work my numerator first. Since this is an addition, I'm going to multiply these two. So I'm going to end up with log 72. Let me just make sure. Yeah. I'm just so slow nowadays. Yep, 72. So log 72 minus log 3. What do I do now? I'm there's a subtraction between logs. I'm going to end up with log 72 over 3. To finish, you're going to simplify this division. Again, when you simplify this, you end up with log 24. Common log 24. And that's it. Note, I am able to divide these numbers because the log is applying to both. Remember that if I had different logs, for example, if I had log 25 over log 35, these are different bases, I can't just divide and simplify. But in this case, as I bunched everything up and I just finished with a fraction, I am able to simplify this very long expression into just common log 24. And that is condensation. That's it for today's class. Now, please do the homework. Please ask questions. We will have an exam for chapter 6 soon, like very soon, like maybe next Monday. So make sure you're studying. Now for homework, please do the following. We're going to do example 1, example 2, and example 3 exercises. Please do 3 through 8, which are very important. Those are the exercises using the numbers. And again, here you're going to be given negative exponents and fractions. And now you have to review the rules of the powers and exponents because they apply to these rules. You'll see I'll probably end up with some questions, but you do have to review the rules of the powers and exponents. So these are all example 1. Please go ahead and do those. Then go ahead and do 13, 18, 13 and 18, which is expanding, and then please do 23, 26, and 29, which is condensation. Again, if you have any questions, please let me know. I'll be able to answer your questions in the afternoon. In the morning, I will be busy. But just let me know if you have any questions. This is the homework. Make sure you turn it in before today, 11 p.m. If you have any questions, let me know. Otherwise, have a great day. See you soon.